Hey everyone. So yesterday we left off talking about the different latitude zones. We have our polar, tropic, temperate. We also talked about how wind moves globally. It goes from the polar region towards the tropics. And we also talked about the Coriolis effect, which basically just causes winds to change their path. So now what we're going to do is finish up our notes. We're going to be talking about land and sea breezes. We're going to be talking about how wind will affect the climate as well as how water affects the climate. So we'll start with this slide, land and sea breezes. Um, Basically, this is one last component to wind and how wind could affect a particular area and its weather, and then therefore its climate over time. So basically, we have two types of breezes. We have land breezes and sea breezes. And as you could probably guess, they happen where there is a large body of water. It doesn't have to literally be a sea, it could be an ocean, that kind of deal. But it needs to happen along a coastal area that has a large body of water nearby. Could even be a very large lake, but it's not going to happen next to like your pool, for example. And the key thing to understand that really makes this possible is that water and land have different heating abilities. So basically, what that means is that water is going to heat up a lot slower than the land will, especially sand. So if you think about any time that you've boiled water or if you've seen your parents boil water, it usually takes a pretty long time for it to get to an actual boil. Um, Imagine how long it takes for a large body of water to get heated up. Now, obviously, it's not going to boil, but it can still take a pretty long time for it to get warm. So, that difference in heating, it takes water a lot more time to heat up, is what actually causes a land and a sea breeze. So, you have water, takes a bit more time to warm up, and is able to retain the heat longer than land does. So again, even though it takes a long time to heat up, it'll actually stay hotter for longer than the land does. And that's going to be key when we have our land and sea breezes. So this won't just affect day-to-day weather, but if you live in a coastal area, having these land and sea breezes day after day after day after day could actually cause a change in your climate. So let's talk about land breezes and sea breeze a little bit more in depth. So on the left here, we have a sea breeze, okay? And it says cool sea breeze moving towards land. Basically what happens is since, and you can see that there's a sun out, so that means it's daytime. Since it's morning, okay, the sun has just risen. The land is going to heat up a lot faster than the water does. And if you've ever gone to the beach in the morning, you may notice that that's true. Like it feels real nice when you get on the beach, you sit down, you're like, great, let's go in the water. You go in the water and it's pretty cold. Anytime it's the morning, it's going to take some time for the water to actually heat up. So we have basically cooler air over the water and warmer air over land. Now, yesterday we talked about how higher pressure areas are typically cooler and lower pressure areas are typically warmer. Well, we have that going on right here. We basically have a cool area and it's going to have high pressure. We have a warmer area, it's going to be low pressure. And guess what? We said high pressure moves to low pressure, and then there we go. Okay, so with that, that makes a sea breeze. Okay, when cool air over the sea blows towards the land. And pretty much if you're on land right here, you're going to be experiencing a breeze. And again, if you've ever been to the beach in the morning, you realize that, yup, the water's real cold, and yup, it could be pretty windy in the morning. And then as the day progresses, it gets less windy and less windy. So that's a sea breeze. Okay, we call the breeze what we name it for where the wind is coming from. If it's coming from the sea, we call it a sea breeze. Okay, and in this instance, since the air over the sea is cooler, it's going to blow towards land. It's a sea breeze. Now, on the flip side, we have a land breeze. And basically, this happens once the sun sets and it gets cooler, we get a land breeze. Okay, so now the land has cooled off because the sun has set, but the water is just finally gotten warm. And like we said, it retains heat longer, so it stays warmer. So basically, what we have is cool land, warm water. So now it's flip flopped. Cool air is going to be over land, and warm air is going to be over the water. Now we have a land breeze. Okay, it still goes from the cooler area towards the warmer area, but now the water is actually warmer because it's had all day to heat up underneath the sun. And then when the sun sets, it's going to keep that heat for a little bit longer. Okay, throughout the night, it'll get cooler, but immediately once the sun sets, it's going to be pretty warm, at least. So if you've ever been to the beach at night, you normally wouldn't feel a breeze if you were doing any like nighttime fishing per se, who knows. So that's pretty much our deal with our land and sea breezes. Land breezes happen when cool air from land blows towards sea. Sea breezes happen when cool air over the water blows towards land. So I do have a video to show you. So we'll play that. There are some interesting sound effects.
That creates two different areas of pressure. That means low pressure is existing over the land, again, because the warm air is leaving that spot. And across the sea, there's an area of high pressure. That air is sinking and pushing down on that area over the sea. There you've got it. The rule is high pressure air always moves towards low pressure air. Air will move wherever there's a space. And since there's been a space created over the land, air will gradually just naturally push its way over there. And that's what wind is. When air is being moved in large quantities across the surface or in the atmosphere. So since we have a high pressure area over the sea, a low pressure area over the land, the rule is high pressure air always moves towards low pressure air. And now we have a movement, wind, moving from the sea over to the land. We name it a sea breeze because the rule is you name a breeze or a wind by where it originated from, where it came from. In other words, where is the high pressure? In this case, because the high pressure is over the sea and the air is coming towards the land, we name it a sea breeze. And you can see the collection of all your previous instruction kind of pulling together into this picture. So there we have a sea breeze, but there's also such a thing as a land breeze. In order for a land breeze to work, the pressure over the land would have to be higher than over the sea. The entire cycle would have to go the complete opposite direction. But based on our picture, how is that possible? So we're going to take a moment here and think about it. And the video is going to be paused for just a second and have a discussion. What factor would need to change in order for this cycle to go the other direction?
You can think about it to yourself now.
In order for the wind to go the other direction, one important factor had to change, and that is it had to happen at night. The reason why it has to happen at night for the cycle to go the other direction is again linked back to our investigation when we heated the earth materials. After we turned off the heat lamp, we allowed the materials to cool off, and we noticed that the land substances, the sand and the soil, drop temperatures much more quickly than the water. That's because water has a high heat capacity. Not only does it take more energy for it to heat up, once it does heat up, it takes a lot of time, a lot of energy for it to cool off. Therefore, it will remain warmer longer, but the land temperatures will drop quicker. And that's the only factor that had to change. So, since that happens, and at night the land would be cooler than the sea temperatures, by conduction, we would have two different temperature air. Warm air would be over the sea, and cool air would now be over the land. You can see already that's enough to cause the cycle to go the other direction. Warm air rises and cool air sinks. And just as before, if warm air is leaving an area, that area has less pressure than it did before. Which then, of course, also means that as cold air is sinking over an area, more pressure is added to that area because you can see the arrow is pushing down over the land now. So now, high pressure over the land. And of course, high pressure air always moves towards low pressure air. So now we have not a sea breeze because it's not originating from the sea. The high pressure is now over the land. And since the air is moving across the land toward the sea, it's called a land breeze.
Okay, so let's head back to our notes. So that's pretty much our difference between sea breezes and land breezes. Now what we're going to do is take a look at how wind in general affects the climate. So this goes back to how wind across the globe, remember we said it goes from the polar region to the tropics. How will that affect the climate? How will the Coriolis effect affect the climate? And how will land and sea breezes affect the climate? So basically when it comes to the quiz or the test or what have you, you only need to know one of these three things, okay? So basically you're either going to tell me, oh, wind will affect the temperature because it will make the area cooler than normal because wind is coming from the polar region. Done. You don't need to go into temperature and cloud coverage and humidity and precipitation. You just need to pick one of them. So if you want to say, oh, wind will change the humidity because when air from the polar region goes into the tropics, it pushes up the air near the tropics, it will make a cloud and then it will rain. That's fine too. Okay. Yes, they are kind of really closely related, but you only need to tell me one of these three things. Okay, so we have wind can change the temperature as air from the polar region moves down towards the tropics. And that's going to make it colder. Okay, so since that cold air comes into the area, the temperature would be slightly cooler than it would be had there been no wind. Okay, so we see again the polar region whoop, going down towards the tropics. Now the next part is actually going to take a look at this over here. When the cold air comes down from the tropics, it's actually going to push the tropic air, the warm air up. Okay, and if it pushes it up into our atmosphere, we know, thinking back to the water cycle, we're going to have clouds. It's going to cool, it's going to condense, and then it's going to make clouds. So that's what we have here. Wind can change cloud coverage and precipitation when warm, low pressure air near the equator rises into the atmosphere. So again, if it pushes down, if the air comes from the polar region, pushes the air from the tropics upwards, it's going to rise into the atmosphere and it will make a cloud. Okay, so when cool air rushes into the area, it pushes the air near the equator up into the atmosphere. As we know, when air rises, it will cool and condense, and we know that condensation will make clouds. And that's actually why typically over the equator, it is rather cloudy. And this actually goes into our next part where wind will change the precipitation because obviously if there's more clouds, it's going to rain more frequently. And that's also why we have most of our rainforests around the equator, okay? We have lots of clouds and lots of rain because we have that global wind circulation near the equator. So that's a kind of cool point, and we get to see it in action. So that's basically how wind affects the climate. Now I will show you later on, I have a diagram of like what you need to know for the quiz or the test when I ask you how does wind affect the climate. I'll show you that once we talk about water a little bit. All right, so ocean currents are next. So now we're going to kind of transition into water and how water affects the climate. So just like air, water is going to move as its density changes. So we said that cold water has higher pressure cold air has higher pressure, warmer air has lower pressure. The same thing is true of water. Cold water has higher density. It's actually going to sink. And warm water is less dense. It's going to stay near the surface or higher up. It's kind of the same thing with air as it is water. Cold air stays along the surface and warm air rises into the atmosphere. Cold water sinks to the bottom and warm water stays near the surface, higher up. So that's one thing that's important to know. Also, one thing that could change the way that water moves, if it's going to be near the bottom of the ocean or near the surface, is the salinity. And salinity means salt content. So if anyone has contacts and you use saline solution to store them in, that is the root word for salt. So saline, salt, salinity. So if you have water that is salty, has more salt in it, it's going to sink near the bottom of the ocean, and water that's less salty, has less salt in it, is going to stay near the surface. Now, this is going to cause a kind of motion of water sinking and warm water taking its place. Colder and salty water sinks, warm water takes its place. Cold and salty water sinks, warm water takes its place. And that cycle is known as oceanic convection. Basically, it's creating a cycle of water moving back and forth and back and forth. Now, this is what creates the currents that we see over here. So these show popular currents or kind of known currents that exist on Earth. Typically, if it originates near the equator, it's going to be a warm surface current. So if we look here, this one right here is actually the Gulf Stream. It comes from the equator all the way around, blah, 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 and it's a surface current. So it's going to bring us heat, which we'll see in a video is good. On the flip side, once it hits the poles and it finally cools off and it comes back, then it's a cold current, okay? So if it originates at the equator, it's going to be warm. If it originates at the polar region, it's going to be cold. So we're going to watch a short video on currents, and then we're going to go from there. Now there are a few videos on here on this slide. The first video you can watch when you get the notes. First video shows you kind of colder salty water sinking and warm water taking its place. The second one we're going to watch, and the third one is another video on currents that you can watch as well. So we will go here.
The ocean conveyor belt and the Gulf Stream. Ocean currents have a direct influence on our lives. They determine our weather, our climate, and much more. The ocean currents and wind systems transport heat from the equator to the poles and operate like a large engine for the global climate. In the oceans, there are numerous currents. The so-called ocean conveyor belt is very important for our climate. This term describes a combination of currents that result in 4 of the 5 global oceans exchanging water with each other. They form a worldwide circulation system. The conveyor belt is also called the thermohaline circulation, with thermo referring to the temperature and haline to the salt content of the water. Both determine the density of the water. While the masses of water may be moved in part by wind, primarily the different densities of the global oceans are responsible for their movement. Warm water has a lower density and rises, while cold water sinks. The water's density also increases with a higher salt content. At the equator, the heat from the sun is especially strong, resulting in a lot of evaporation and thus a rise in the water's salt content. That is where the Gulf Stream begins. The Gulf Stream is very important for the European climate. Its length of 10,000 kilometers makes it one of the largest and fastest ocean currents on Earth, and it's very warm. At roughly 2 meters a second, it brings up to 100 million cubic meters of water per second towards Europe. A constantly blowing wind, the southeast trade wind, drives warm surface water to the northwest into the Gulf of Mexico, where it heats up to 30 degrees Celsius.
All right, so this next part is pretty important, so let's watch this.
Turning of the Earth and the west winds then direct the Gulf Stream towards Europe and split it up. One part flows south, another east to the Canary Current, and a third part flows north, where it releases a lot of heat into the atmosphere as the North Atlantic Current. The water becomes colder there. Its salt content and density rise on account of evaporation, and it drops down between Greenland, Norway, and Iceland. There we also find the largest waterfall on Earth, the so-called chimneys, roughly 15-kilometer wide pillars with water falling up to 4,000 meters. 17 million cubic meters of water per second, or roughly 15 times more water than is carried by all the rivers in the world. This creates a strong maelstrom which constantly pulls in new water, and is the reason that the Gulf Stream moves towards Europe. Countless species use the Gulf Stream as a means of transport on their trips from the Caribbean to northern areas. But it doesn't just bring us animals. An enormous quantity of warm air also comes with it. In order to reduce the...
So this is important. It says, in order to produce the same amount of warm air that the Gulf Stream brings to Europe, it would need
same heat which it brings to the shores of Europe, we would need 1 million nuclear power plants. That's why we also call the Gulf Stream a heat pump. Without it, the temperature would be significantly colder here, at least 5 to 10 degrees. Instead of lush fields, we would have long winters and sparse ice-covered landscapes in Europe. In the last few years, scientists and pundits in the media have repeatedly expressed the fear that the Gulf Stream could come to a standstill due to climate change. Because if the polar caps actually melt, the salt content in the water off Greenland would fall, as would its density. The North Atlantic Current would no longer be heavy enough, and so it wouldn't sink as usual. In the worst case, that would bring the Gulf Stream, our heat pump, to a stop. Some climate experts also assume that climate change could compensate for this effect. We know that it can be normal for the climate to change by looking at the development of the Earth over the last few million years. There are ice ages and warm periods. In the last ice age, a gigantic flood of melting water crippled the heat-bringing North Atlantic Current, covering the northern hemisphere in ice. Scientists have different views on the impact that climate change will have on the global ocean conveyor belt. But one thing is clear, when the climate changes, then the complex system of ocean currents and winds, which has remained fairly stable since the last ice age, will change in ways that we don't yet understand.
Okay, so that last bit kind of went over what would happen if some of these currents were to change. It does have a pretty big effect on the climate. All right, so now we're going to go into our last part, which is pretty much how does water affect the climate? And just like when we said how wind affects the climate, you only need to choose one of these 4 things, okay, and explain that on the quiz or the test, okay? So you could say, oh yeah, water currents could change the wind, or water currents could change the cloud coverage, or water currents could change the humidity, etc. So you're only choosing one, and then you are explaining it. So we'll go over the first one, which is how it can make the area windier. And basically, if you're near a large body of water, it's possible for a sea breeze to occur. And if a sea breeze occurs, the shore is going to be windier than normal. Okay, this kind of shows the shore. This is the water. A sea breeze is going to cause cool air to go onto land, and it's going to be windier. This next part talks about cloud coverage. So if we do have a sea breeze, because you live next to water, it's also likely to be a little bit cloudier near coastal regions. Basically, if you have that sea breeze, the air is pushing in from the water, the cooler air over water is pushing in onto land. It's pushing the warm air up, and anytime we have air rising, it's likely that clouds will form. Finally, if you live near water, it is more likely to be humid. Why? Because there's more water to be evaporated. Kind of makes sense. If you live in the desert, it's not going to be humid. Why? Because there's no water to be evaporated. But if you live next to a large body of water, there's more. So that kind of is pretty self-explanatory, a nice, easy one to explain. So water could make the area more humid because there's more water to be evaporated. And then finally, water could also change the temperature. It could keep coastal areas cooler than normal because water takes longer to heat up. So basically, if you think of it this way, in the springtime in New Jersey, if you go to areas along the coast, it's going to be colder than if you are in Swedesboro and Woolwich because they're right next to the water. That water has gotten cold all winter, and it kind of acts as almost like an ice pack, and it will cool down the coast just a little bit, just a few little degrees. But in the flip side, the areas on the coastal area of New Jersey are also going to be warmer in the fall because it's had all summer to heat up. So now it's going to act as like a sterno, and it's going to keep the area a little bit warmer than it normally would be. So water can keep coastal areas cooler than normal in the springtime, and it can also keep areas warmer than normal in the fall. So that's basically it. Remember, when you're talking about how water affects the climate, okay, we only need you to answer one of these things. If we're talking about how wind affects the climate, you only need to tell us about one of these things. So I'm going to show you a chart that I'll scan in and you'll have access to today that will show you kind of what we're looking at. And again, it's kind of blurry, I apologize, but you'll be able to see the scanned version. Basically, on a quiz or the test, for wind, you pick one of these, just one, and then explain it. So if you want to say that wind affects the temperature, you can say wind affects the temperature because air from the polar region, which is cooler and high pressure, rushes into the tropics, making it cooler than before. Period, done. You don't need to talk about these two. If you want to say that wind creates a change in humidity or precipitation, you could. You could say wind causes a change in humidity because if there are more clouds in areas that are more windy, those areas are more likely to experience rain. Done. Okay? Same thing goes for water. Okay? We have 4 options. You choose one of them. Water can make it more humid because if you live nearby a large body of water, the air is more likely to be humid as the water evaporates. Period, done. So pretty much you just choose one of these each and explain it, okay? So for today, you guys have watched the video. The last thing you need to do is do the exit pass and then hit turn in, obviously. And then for the rest of the week after today, You guys are just going to be working on the worksheet, okay? So I'll be around. You can ask any questions on assignment, comments, and that's about it. Good luck. I hope you guys are doing well, and I'll talk to you soon.